All right, very good. Very interesting discussion about this port project. Congratulations for the presentation and also the interesting questions. So let's begin with my part. This is my second presentation in this stage. Yesterday was the first one. So my name is Afonso. I represent CYPE. CYPE is a Spanish company that develops software for structural engineering. And after my presentation yesterday, I received some of you in our booth here outside and some interesting questions and discussions about BIM and structural engineering we had there. And one common situation, one common comment that I've heard is, I'm structural engineering, I'm not doing BIM. These are separated disciplines. So BIM and structural engineering are in different parts of the project. And as I had this second presentation for today, I decided to prepare two examples, two cases, showing how structural engineering and building information modeling are very integrated. So in our perspective, in our way of thinking at CYPE, we don't have different disciplines. We use BIM to structural engineering, or we can design our structures and has as a mean or as a deliverable the BIM models. And that could be for steel structures, for concrete structures, for the design of the foundations, for retaining elements. And I think this is a good opportunity to show the way that we think when we develop our softwares. So I prepared two examples that I'll be showing to you. I promise that it's not going to be a boring PowerPoint presentation. I'll try to use the software that is my natural habitat, let's say like this. And I prepared two examples. One related to structural design. It's going to be a little workflow where we can see where is the analysis, where is the design of the connections, and where is the steel detailing process, integrating everything using building information modeling. And if we have time, crossing fingers here, we also do a little example showing a concrete structure that is integrated with more disciplines of the project, with all the details that are necessary. So yesterday I presented this slide where I showed one model that was in the initial part of our process, in the analysis and in the design of the sections, that could be used to then design the connections and then feed back the first model with, for example, the rotational stiffness that we can calculate when we design the connection and use it again for the analysis or the main analysis. I'll try to show this example to you in this presentation. So, for example, in this situation when we talk about steel structures, there are different ways to introduce the information to create our project. So it's usually what we call the data input. Could be a DWG file, a DXF file, an IFC file that we learned yesterday. What exactly is that? Could be a BIM model from Revit, from Tekla, from ArchiCAD, or any other BIM software that can export IFC software. Could be even the software itself that we just open the software and from scratch we model our structure. Okay? So we divide here in our ecosystem. The analysis phase is going to be in one software called CYPE 3D. Don't worry about the names now. Just remember it's part of the same ecosystem. And in a second moment, the information that we design here will be used to detail here and design the connections, creating what is the model for manufacturing or for fabrication. So I'll try to do this little workflow using some examples, opening the software, okay? So let's go there. Let's close the PowerPoint here. And I left here some models, some softwares working. For example, this is the first one. Here I have a project where I design a little structure. This is what is going to be my analytical model of this structure. Here I have different options to decide how I will design the structure. For example, what's going to be the code that I'll be using for the different type of materials that I'll be using. Also here, I can set the combinations for the limit states that the software will generate for me. Or, for example, if I want to consider or not the seismic loads in my project, considering, for example, the NSP 2015 to generate all these seismic loads automatically. Could be something similar for the wind loads. So all the parameters that are related to analysis, we'll define here in the beginning of the project. Then later, what we can do is go to the other parts of the software and decide how it's going to be, for example, the section of the different sections that we apply in the structure. Rolled steel, built-up sections, code format steel, different sections that we can create or even customize if it's necessary. Once we have this first part, the geometry and the properties, we can apply the loads that will be happening in our project. Different loads, different types of loads. Loads applied directly in the nodes, in the bars. We can create shells, panels, okay? And then we'll proceed to the analysis. This project, I already analyzed it. So for example, here I can see some forces, some moments that I'm applying here, moments that we are generating here, not just the moments, also the shear, axial forces, also other information related to the deformed shapes of the structure. So this is an analytical model. This is analysis and design. The software actually will not just analyze the structure, but will also select the best section for me in a series of sections. So for example, in this case, in this series, the minimum one is 220, and the software can select it for me, okay? So when I'm creating this analytical model, and even, for example, analyzing all the checks that we are doing, according to a code, this button here, let me show to you, all the checks that we are doing, we are also creating our first BIM model. A first BIM model, which the level of development, the level of information that we have, it's a very basic BIM model. A BIM model that is generated automatically from the analytical model. So if I turn on here, you can see that my BIM model, that for certain purposes could be very useful to estimate the weight of the structure, to have some types of drawings. Even in certain projects, just this BIM model is more than enough, okay? But in certain situations, we have to prepare and add more information, develop even more this model. Not what we got from the analytical model is enough. So this is where Open BIM becomes the protagonism. This is the place where we can start connecting two or more applications in the same workflow using open standards as we talked yesterday, using IFC. For example, in my case here, what I did is using one feature that is available here, connecting this project with a folder in the cloud. I shared this analytical model with this first BIM model to this folder. And then in a second program that I have here, I imported the same structure. And in this program, my goal is design the connections and create all the shop drawings, the manufacturing models of the same structure, but they are integrated. And there is one thing here that is very, very interesting. Those moments and shears and forces that we saw in one of these nodes, they will be transferred from the main model to this model here. Why we should have here forces and information related to the analysis if this is detailing? Because when we start detailing and creating these connections, we'll be not just developing the model for the manufacturing, but also calculating the rotational stiffness of these elements here. The number of bolts, the type of the bolts, the position of the welds, the thickness of the plates that we decide to include in these connections will define if this is a real pinned or fixed connection. This is not just 0 or 1 or a number that we can get from a bibliography. You can model this connection, you can estimate this rotational stiffness, and if you want, you can send it back to your main analysis and update your analytical model. So this is the power of Open BIM in this sense. So one thing that until now it was just drawing, it was just detailing. Now with this new information we can use to have a more precise coefficient to the connections to the nodes that we have in our analytical model. So let me show one example. I'll do one very simple just to be very, very quick here. So if I zoom here, I already created some connections, but when I click and select 3 or more elements that are reaching a node, I open the connection editor, or as we say, the CYPE Connect. This is an interface to model a connection like this. Actually, in the beginning, when I started the project and the model came from the analysis part, the node was like this. No treatments. It was just a raw node. Everything here is clashing. Actually, the software is telling to me, watch out, there are elements clashing here. But then, using different options that I have here, I can start adding operations to manipulate and model this connection, adding steel plates, bolts, welds, until I create my connection. And for each one of these operations that you see here, I have different parameters. For example, these bolts that I'm introducing here, I'm selecting which plate I'm connecting, what kind of bolt I'm using, if this bolt's gonna be executed on-site or at workshop. That's very important, because later we can have different quantities for site and workshop, or the assemblies that we will have in the project later, they will be defined according to this selection. So every time that I need to personalize something, I can personalize using these operations and then changing the parameters that are here. Once I have my connection created, I can save this connection. I can save it for my library and use in future projects, for example. Or I can go to the analysis phase. So this is very interesting. The model that the connection that I model, combined with the load cases that I just imported from the main model, the analysis model, and also, of course, the loads itself for each load case of the project, now I can analyze this project. I can, for example, estimate the stress and the strength of this connection, okay? For this process, we are using the OpenSys engine. OpenSys is developed in California by the University of Berkeley. And with this engine, we can do 3 or 4 interesting things here. The first thing is we can know in this graphical area if the elements are safe or not. So for example, in a scale from 0 to 100, that is here, just before the red area, we can see the maximum demand capacity ratio. So how much of the resistance of these elements we are using. I can see that the welds there, the sections here, this plate here, they're very safe. We are using just less than 20% of the maximum. The orange bolts, a little bit, it's still okay, between 60 and 80. The blue one, 20/40. So my connection is correct. But I can also see here that according to the NSCP that I've selected in the beginning of the project, the code that I selected, all the parameters related to the different topics of the NSCP, they are described here. And I can see why the connection is safe. Not just because the color is telling to me, but because all the calculation is described here. And this is a BIM model. Because I'm increasing the level of detail of my BIM model, because now I'm adding these connections. And in the moment I'm calculating this connection, that there's a button there, I'm also calculating the rotational stiffness of these bars reaching the main one. I'm also creating the detail for fabrication. So this is the place where there is no more difference between structural analysis or structural design, structural engineering, and building information modeling. Everything now is very integrated. So in the moment that I finish that, I know it's correct, it's safe. What I can do is, let's print some drawings. Let's generate, for example, the shop drawings of this connection. Yeah, it's one simple example. This is a BIM model. So if it's a BIM model, there is information behind the model. It's not just geometry. So for example, if I click in one of these bolts, I know exactly what kind of bolt is that. Or if I click in one of these plates, same situation. And in the future, if it's necessary, and I have to come back and change the connection, change the type of bolt, the number of the bolts, the type of welds, this information will be updated automatically because it's a BIM model. A BIM model that was used to create an analytical model. Actually, if I come back here to my analysis, look, my finite element model is here, okay, for each combination of my project, showing the worst cases and the failed checks if it's the case. not just the von Mises stress, but also, for example, the displacements. And that would be also to calculate the rotational stiffness and the local buckling of these elements. So it's an analytical model integrated in a BIM model. So the geometry of my BIM model, the information of BIM model is feeding my analytical model, everything integrated here. But this is just a zoom in one node, one connection of our structure. If I accept this, my connection will be integrated in the model. And I can keep doing that for all the other connections of my project, using some tools that we have to automate this process if it's necessary. There is one concept here that is very interesting. If I come here, there is a button called Assemblies. And if I hover my mouse in this beam, look that I'm highlighting exactly the plate that is welded here, but not highlighting the bolts. I'm not selecting the bolts. Why? Because I decided when I designed this connection that the weld is going to be at workshop and the bolt on site. So my assembly is considering just those elements that I've selected there are at workshop. If we go there, we can see the same. The main plate is highlighted, the welds, the main section, but the bolts not. And actually, if I click here, the software will generate for me one paper where I can describe my assembly exactly with the elements that were described in the design of the connections. There's one interesting thing here. If it's an assembly, maybe it would be very useful to have a table with all the pieces, all the parts, all the materials that are exactly in this assemble. Because then for manufacturing that, knowing that we have 8 little plates or 2 big plates, one IPE 300, the section, it's very, very useful. So automation, because now we are using the part that is the build information modeling that came from our analysis, okay? Very good. So in case we need, we can use the platform, the common data environment that we presented yesterday to send this model back to the first software and feed all those nodes with new values of rotational stiffness, and then we can recalculate the structure with a more precise number. So it's also, it can also feed back. It's not just one way, it's a cycle, okay? It's a cycle. Okay, here we don't have too much time, so this is a little example of steel structures. But let me show you another example for a concrete structure. Let me just show this little example here. This is a little structure where I'm visualizing here a federated model, a model that is made by 2 layers here, architecture and structures. Actually, if I turn off my architectural layer, actually there are a lot of layers that are in architecture, I can see my structure here, okay? This structure actually, if you see here, the structure is here, but there are a lot of sub-layers because even the data from my analytical model can be visualized here, integrated. For example, if I turn off the structure for a while, you can see which elements I consider as shear walls in my project, the core of my building. Or I can see, for example, here, some deformed shapes related, for example, to the dead loads or the different modes that I have for my earthquake analysis, or even here, the different deformed shapes related to the wind directions, the different wind loads in different directions. But look, in my BIM model, now I can see results from the analysis. It's totally integrated. And one of the results that we can have from this process of designing something, let me show to you, is, for example, generate what is the main part of our structure, the rebars. So the rebars, they are one of the deliverables, one of the results that we can get from this system where when you are designing, when you are analyzing, you are also generating your BIM model. A very detailed BIM model. Each color here represents one different diameter. And this is just the same effort that you have when you design the structure. You don't have to do any extra thing to have this. It's just there. But probably, if we have to go to the field, if we have to construct that, will not go to the field with an iPad, open a nice model like this, inspect, raining, mud. No, that's very good. That's what we want to do. Maybe in certain countries, very developed projects, they're doing that. But the reality is, I want to have a nice shop drawing, a nice 2D DWG file with these rebars. How can I get that? Let me show to you. If I open the same project, but now looking for the perspective of the structural engineer, I can see here a 2D view of one of the floors of this structure. Here, I can also see in an integrated view. It means, as a structural engineer, I can see also here the architecture. But now, I cannot change the type of windows, move the sofa, because that's the architect part. My part here is the structural part. And actually, the structural part that I have been working here, it's behind, let me show to you, behind architecture. The same situation, but looking for the other perspective. And from here, in this software, if I open, for example, my results, we are here in our field. Here, we can see the format shapes, we can see contour plots, we can see all the different forces in beams, columns, etc. For example, if I click in one of these beams, let me show to you here. I'll open one of these beams and click. The software is generating for me these drawings automatically, the drawings that will be very useful to the project. And this is a BIM editor. The software will do the best that the software can to do the best drawing for us, verifying if it's safe or not according to the code that we selected. But sometimes the way that we create our details is not standard. So this is a BIM editor where we can change how I want to have the longitudinal bars, what's going to be the bend, the diameter, the length of the hooks. So everything can be personalized. And in this area, what you see here is the beam, and the top part of the beam, the bottom part of the beam, and the green lines, they represent the minimum steel area for each part of the section. And the red, they represent the red represents the minimum, the green what we have. So every time my green area is more than my red, it means that we are safe. So if I decide to change the arrangement of my reinforcements, immediately this area will change. And if this line crosses, it means that it's not still enough. This is structural engineering, but we are using a BIM model for that. So where is they're together, okay? And of course, this BIM is gonna be, in the future, one of the DWGs that we will export and send to the field. But there are tools to do that. This is just to have an idea and personalize, customize the BIM that we are generating. Another thing that I think it's maybe one of the most important parts is this one. If I click in one of these spans, I can see all the checks that I have been doing here to the ultimate limit states. So in a BIM like this, just one span of one of my multiple BIMs, I have all these checks here, checks that are related to resistance, checks that are related to cracking, deflection, always considering and describing how this check was made, okay? And if it's failing, it appears here. It's not going to be in green color, it's going to be red, and telling why it's failing. So this is maybe one page or one part of a page of your final calculation report that you can print later, okay? Getting information, again, from the BIM model. So another example that I can show to you here, if it, for example, I click in one column, very similar. It's a different panel, but in this column, I can personalize and change all the parameters related to this column. I can see, for example, that in this project, I have some columns that were grouped automatically by the software because they are exactly the same columns in different locations of the project. I can also see that in one of these groups, there are some columns that are not safe yet, that I have to still work on that. Or I can see the position of these columns in my project. I can also see here something very similar to what we saw for the beams. We can see the detailing, we can see the checks, okay? So it's quite similar. Here in this project, we can also see, for example, if we talk about the slabs, contour plots, showing to us different information that are related to the load cases that we have in the project. For example, the different displacements, rotation, okay, for different directions here. Also, forces of the project, design forces, ratios. So this is information from the analysis. But again, very, very integrated in the BIM model. And when we have different load cases, we can see even these results for the different load cases or different combinations when is the case, okay? One part that I think it's very important is the Philippines is a country with a very high seismic, and this is a challenge sometimes. And for building this size, we need to introduce this seismic loads. So I'm not an expert in the seismic design in the Philippines, but using the options that I have in the software, following the same steps that are there, I can introduce the parameters and analyze the structure even in a seismic area here in the Philippines. And one thing that I think it's important to share to you is, for example, some reports that we can have from the project, including the seismic reports. So all these buttons that you see now in the screen, some of them are blocked, are in gray. They represent all the types of documents that you can export from this structure. Those that are blocked, that are in gray, they're blocked because we don't have materials or structural systems in this structure that are related to that type of report. For example, in this project, I didn't include steel decks or waffle slabs. So the steel decks report that should be somewhere here is blocked because I don't have this type of system. So in this very simple system, I have all these reports available. And there is one here that is called the justification of seismic action. Let me just open it. It's this one here. And I think this is a very interesting one. For this project, it's 14 pages. These reports you can personalize. You can change the color of the size of the fonts. You can add your own logo. You can send it to Microsoft Word and change later. So it's just a report. Here I can see the codes that I use it to the project. I can see here, for example, the design spectrum. I can see here the design acceleration spectrum. I can see here the participation coefficients, mode by mode. It's possible to then, in the beginning, I didn't show it, but you select what's the percentage, the 90% of the mass. You can select this kind of parameters to reach these modes, okay? You can see here, look, this one is very interesting. You can see the center of mass and the center of stiffness for each one of the floors. Okay, this is a very symmetrical structure, so they're coincident, almost coincident, but if it's not symmetrical, maybe you have to think about that. So these kind of things, again, results that we are getting from the BIM model, but we can also get from the analysis and generate a BIM model. So it's interactive, very interactive. Okay? Another type, I will not cover all the reports that we have here, but it's quite similar, the process. But another thing that is interesting is this other feature here. I can select, create a list of drawings that I want to extract from this model and prepare the DWGs or the PDFs from this BIM model automatically. So I prepared here a list of them, and just by clicking here and waiting maybe 20 seconds, 30 seconds, we will generate a lot of drawings automatically that you can customize. You can change the aspect, you can change the thickness of the layers, you can add your own title block. Again, extracting this information from the BIM model. Okay, let me just accept here. One more. And for example, all these squares, they represent all the papers that I extracted from the project. A1, A2, A4, A3, okay? And just zooming in some of them, this is one example, one of the columns that the software generated for me. Or for example, let me show here another one that is interesting. The bins, some of the bins that I've generated here, with the bar schedule here that was included, frame by frame with the position, the diameters that we have here, summarizing the diameters in this frame, okay? Or one more here, one of the different layouts, the floor plans that we have in the project. I think I didn't show it to you, but even also the foundations are possible. No, in this one I don't have the foundation. What else? The idea here is you are creating these DWG files to then export it in PDF, in DWG, print it, and this is gonna go to the field. So I know maybe this is a lot of information. I'm finishing here my last minute, but my message was, BIM and structural engineering, they are not separated disciplines. They can be used together. You can use it just for simple integration of disciplines, like in this little model here, where I have more than the structure and the architecture. I also have here other disciplines, but you can also use the BIM or the structural design process itself, as we saw with the connections, for example. Okay? Thank you very much. This is my message today.